So as people join.
Can you hear me?
So Jeff, I can hear you over the meeting. I'm not sure if that's intentional. So so far we've had Wim, Hendricks, and Shuping Peng confirm that they have audio, two-way audio connectivity. So in general, there are two buttons for the microphone, to be clear. There's one that has a hand next to it, and that places you in the queue. It doesn't actually unmute your mic. So you can actually just unmute your mic by selecting the button with the triangle next to it. That enables your audio, basically unmutes you immediately. So so far I've gotten confirmation from Wim and Shuping Peng that we have audio working. Any other presenters? Yes, I can hear you, Jeff.
Good. And
so any other presenters, it would be good to, if you're on, it would be good to confirm your audio. And again, you don't necessarily need to wait in the queue. During question and answer, it would be good to use the queue, but you can unmute yourself directly by pressing the, okay.
Hello?
Is that Huaymo?
Yes, yes.
Okay, so I can hear you, Huaymo. Thank
Good.
you for confirming.
Thank you.
Okay.
Chris, do you see the status update page?
I do.
Great. So I think we can start. It's time, right?
Okay, sounds good. I guess we will handle the rest of the audio checks in real time. And we'll just get going here. Okay. So I guess I'll run with things for the moment. So welcome to the routing area working group meeting for IETF 108. We have Jeff Tansura and myself, Chris Bowers, as the chairs, and Yingjin Chu acting as secretary. Next slide, please. Are you able to advance the slide, Jeff?
I did. My screen shows not well.
Okay, mine doesn't, which is a bit weird.
Let me try it.
Could another participant perhaps indicate whether or not their screen shows Note well or not?
What do you see?
Still the first slide.
The Rtgwg status.
Yeah.
Let me try to share again.
Okay, I'll try switching to sharing my screen. How about? We'll just go from there.
Great. It's still showing my screen.
Maybe you can try stop sharing and try again.
Yeah. Oh, no, it doesn't share anything at all. Yeah. Oh, all the slots for the requested media are already taken.
Okay, so I just tried sharing mine while you were frozen there. So let me
Oh.
because I hadn't heard from you. So it is extremely slow.
Nothing's coming up, Chris.
Yeah. So I've abandoned my attempt. You attempt again, please.
Okay. Okay. Should be coming up.
Yes, I see an infinite regress of your screen, and I see the note well.
Great.
Okay, so let's move forward from here. Please look at the note well, and it applies to, you know, more or less anything you contribute or say in the context of an IETF meeting. Well, it defines the policies about what applies as a contribution or participation. So please read it and keep that in mind while you are participating in IETF. Next slide, please.
Do you see IPR disclosure?
Unfortunately, I do not. Can someone else chime in as to whether or not we see they see?
Only seeing note well.
Not well still.
Let me try to reshare again.
So I would say within a couple minutes, we should just go to everyone flipping through the slides on their own, since they all have access to them, so that we don't spend our whole.
Okay, what do you see now?
Now I see IPR disclosure.
Okay, let's try.
Okay, so you know, there's general rules about IPR disclosure in IETF. The routing area working group has particular policies where we request that the authors and contributors state their awareness of IPR at two main gates in the working group document process, before the working group adopts an individual draft, and also before the working group requests publication by the ISG, that is at working group last call. Next slide. Hopefully we'll advance. Oh, right. Excellent. So I think I'll skip the agenda review right now and just go straight to the document status update, since we've already used up. So we had a couple of drafts published as RFCs since IETF 106. the PA multi-homing draft, and the Yang model for RIP. So good work. Thanks for getting that done. Expecting to do working group last call soon on BGP pick. We still need IPR responses from 2 out of the 3 authors. Also expect to do a working group last call on policy model, which has gotten a good amount of feedback from reviews from directorates. And we should be doing the Yang RIB extension soon as well. Next slide. So 2 existing working group documents deserve, I think, some special discussion. The routing area working group has a very broad charter. We've got sort of the bread and butter topics, which are fast reroute topics, and also sort of miscellaneous Yang models for routing. But then we have sort of these documents fall into the sort of catch-all basket for the routing area working group. So the routing area chose to try to produce a document about problems in interconnecting enterprises and cloud data centers. Since the working group chose to take this on at its own discretion, I think the working group has an obligation to produce a very high quality document or not publish anything at all. And so when people are, looking at the state of this document, we should really consider, is it ready for publication as it is? And the Shepard write-up has a very important question related to this. It says, is this version of the document, or if this version of the document is not ready for publication, please explain why the document is being forwarded to the IESG. So at this point, I don't think the document is ready for publication. And I think most people reading it would not think that it's ready for publication. The question isn't, will it be ready for publication after the Shepard, does a lot of work on it, and the AD does a lot of work on it, and the IESG does a lot of work on it. The document still needs a lot of work before it should be published. So our goal should be to publish a high quality document, whatever is coming out of the working group, not after it's, been worked on after the working group last call. So I think it's up to the working group to either improve these documents or to decide to park them. So I'll leave it at that, and we can carry on discussion either later on or on the list as well. So recently we adopted SRv6 egress protection, and next slide. We just have these ongoing working group documents, which we don't really have slated for last call soon, but they're actively being worked on, and some are being presented now. So I will close at that, and then we can move on to the first presenter, Asim Chowdhury. So you should be able to speak, Asim.
Okay, can you hear me?
Yes, I can.
Okay, great. Okay, so let me start. Okay, hi everyone, my name is Asim, and I am going to provide updates on QSAN model. Next slide, please. So I'm going to cover status of the draft, recent changes, as well as next steps. Next slide. The draft has been adopted as a working group document. Thanks for the support. We have received additional comments after that. Based on those comments, we have published version 2 of the draft. Next slide. Most of the comments were regarding the references, and we have added as much as references as possible into the draft. Also, there was a clarification required for protocol field in IPv6. As we all know that IPv6 has next header field, not a protocol field, but all the vendors use nomenclature protocol instead of next header. So we have continued with that, but we have provided a lot of description about it. That next header field contains the same information as protocol field in IPv4. It could be part of the extended header, and which may contain further protocol field value. Also, as suggested by the comments, we have removed working group chair name from the YAG models. They was asked to provide a limit on the max value. So we have added that value, that limit, that makes sure that the max value is cannot be less than the minimum value. Besides that, we have fixed some of the typos. Next slide, please. So as next step, we request to provide this community to provide more comments. Please go through the draft and provide any further comments on this. Also, some of the vendor prototyping are in progress to verify the functionality, to make sure that if there is any pending issue in the draft, which can be taken care of. Any questions? Okay, maybe next presentation.
Okay.
Chris, you're watching the
Yeah. So
Jabber, right?
yeah, I unmuted. Okay, there was something going on with the queue there. Okay, yeah, I think we're good with outstanding questions. So yes, let's go on to the next presentation.
Sure. So here I'm going to talk about QS operational YAG model. Next slide. So we had a lot of internal discussion on the name counters, and we realized that name counters can be categorized into aggregated counters and non-aggregated name counters. Next slide. Aggregated name counters are for the platform where there's a low-end platform where there's a limited hardware budget for the counters, and many implementations require that multiple classifier counters can be aggregated into single value. And so the classifier having the same name counter, those counters will be aggregated. This will be applicable only for classification counters, and as aggregation of queuing counter or metering counters will not make sense. Next slide. Also, there's a need for tagging the counters. So for example, if you think from customer perspective, many customers do want to tag various counters in a particular platform, networking device. And by tagging the counters, they want to see a particular set of counters at a particular cadence. For example, multiple classifier or queues counters can be tagged as real-time traffic. And when a particular customer wants to pull the data for the real-time traffic at a particular cadence, they can do so. The advantage of this approach will be that, for example, there are 100 counters in a particular network device, and a customer wants to see only 10 counters on a regular basis. So they can provide a cadence for that, and so that they require much lesser bandwidth, as well as the computational resources requirement will be much lesser. So hence, similarly, the non-real-time traffic can be tagged, or any particular tag can be created. And these tags can be created across classifier, queues, and meters. And not only that, these tags can be created across the interfaces, and they can be pulled through a particular cadence value. Next slide. So if you see the modified name statistics model, we can see that the name statistics model is converted into aggregated model, as well as non-aggregated values. Aggregated name statistics counter will only contain classification counters. Non-aggregated name statistics counters will contain classifier, metering, as well as queuing counters. Next slide. In addition to these changes, we have simplified the node names. For example, many of the names, the prefix of QS was unnecessary, being in some kind of a node hierarchy. So we have removed those unnecessary prefix names and simplified the names, as well as suggested in the other draft, working group chair name has been removed from the Yang model as such. Also, we have fixed some of the typos. Next slide. So as a next step, I will request everybody to go through the draft, provide your useful comments. Also, we are working on adding more references to this model. And once that is done, maybe we can take an adoption call on this draft. Thanks. Any questions?
Okay, I don't see anything on the Jabber queue and nor on the speaking queue.
Okay.
So I see good progress on both drafts. Thank you for doing this work, and please update us as you go through implementation. Really good work.
Absolutely. Yeah, sure. Thank you.
Thank you. The next is a service pass egress, right?
Yes. And I would also note that anyone who was in Spring noted that the session cut off immediately at the time, at the end of the session, the allotted time. So we're going to have to stick to the schedule very strictly. So right now we're perfectly on schedule. So the floor is yours, Huaymo. Are you available, Huaymo?
Hello?
Yep, we can hear you.
Okay, good. So today I'm going to present ESA v6 pass egress protection. Next. So at first, I would say thank Yimin very much for his valuable comments and suggestions around the working group adoption. In addition, I would also say thanks to Zhen Chang, Alex, Greg, Bruno, and Jeff for their valuable comments and suggestions around the working group working group adoption call. So compared to previous version, we have the following updates. We have added more details about the egress protection mechanisms. And secondly, we changed the inset to in-cap in the middle node. And the third one is some editorial changes. So next slide. So this is the rough mechanism for SR egress protection. So basically, the mechanism is same as before. The only difference is that we changed the inset to in-cap in the middle node, because this is one we want to comply with the other document in SR network programming. So here we just brief the mechanism about the egress protection. So we suppose that we have SR pass from PE1 to PEA. So PEA is the egress of SR pass. So for this egress, we would like to have a backup egress, for example, PEB, to protect the active egress nodes. So in order to achieve a protection, so at first, we need to configure on the backup egress node, such as the PEB, and then we configure a mirror ID mirror seed to protect PEA. And then after this configuration, IGP will distribute the information about this information. And then the PEB will create a forwarding table or FIB for node PEA. So node PEA will be the node to be protected. And also we will have forwarding behaviors for the seeds on the node PEA for the forward entry, for forward the package to the same destination as the node to be protected. So when upstream node of the active egress node detect the failure of the egress node, so it will using edge incaps to incap the package. So this incap will have a mirror ID and a source node of P1 in the new header, and then send the package to the backup egress node. So on the backup egress nodes will decap using end.dt6 to decap the package, and then use the mirror ID as a context label to find the node to be protected. Here is the node PEA. The forwarding entry, first find the forwarding table for the PEA, and then in this forwarding table we use the ID to be protected to forward the package to the same destination as the node PEA to be protected. So that's the rough mechanism for egress protection. Next page. So we still would like to have inputs and comments, suggestions for this document. Thank you very much.
Any questions?
So Ketan is in the queue, so I've allowed Ketan. Okay, thank you.
Hello, Ketan Talaulikar from Cisco. I have a couple of questions. One is in the previous slide, the behavior or the how the mirror set is used. Are there any do the authors plan to describe this in either a Spring or this document itself in a more formal and a normative way, as well as perhaps this needs a location of a behavior code point from IANA?
Oh, you mean the transient node behavior?
The mirror set behavior.
The mirror node behavior. Oh no, this is not insert. Originally insert, but because people, as I mentioned, they suggest we shouldn't use insert. We must use incap. So we changed the insert to incap to comply with the SR network programming. I think that one is already.
My question was about the mirror SID, which is instantiated on the PEB. That's a new type of SID behavior, not yet defined for SRv6. And my question was there the author plans to do that?
Yeah, you mean regarding the insert in the middle node?
No, on the PEB in your picture, you have that router is instantiating a mirror SID, right, for the PEA?
Or in the you mean the forwarding table for the node PEA?
Yes, the mirror SID for node PEB. I mean, if it's not clear, we could take it offline as well. I can share it on.
Okay. Yeah, send me email and or whatever.
Okay. And and the second question was that this document is describing the IGP encodings and new TLVs and asking IANA. So do we plan to do it in this document or in a separate LSR document, or have this reviewed in LSR as well? Just wanted to understand the plan there.
Yeah, I think we will send this one for LSR for review, because that's the IGP extension. I think we just follow the normal procedure, and I think that quite a few of our documents did the same thing. They have an extension here for IGP, and then we need to ask those IGP experts to review, to get approval from there, right?
Okay, sure. I think
since
because
document had been adapted as working group, I think it's a good time actually to start discussion on LSR with regards to encoding.
yes, that's what I was. Thank you.
Okay, thank you, Ketan.
So after IETF, please do send it to LSR and ask for review. Please confirm.
Jeff, do you hear me?
Yeah.
Martin speaking. I think the same applies for the mirror seed. Yeah, I think that draft needs to go in front of Spring because it's not part of the architecture right now.
Yeah, can you send me? Maybe you can send about more details about those kind of compliance or whatever.
So to summarize, Ketan asked for formal definition of behavior of the protect seed, and obviously we would like as chairs you to start discussion wider in routing area, specifically in LSR, and presenting this in Spring perhaps next time, because indeed it needs to be reviewed by other people. I think we'll move on. Chris, any more questions here?
No, I think we're good. So we can move on to the next presenter, Zhushang. Yeah. Can you go ahead and speak, Zhushang, just to make sure we have audio? Oops. Can you go ahead and speak, Zhushang?
Yes, I'm here. Can you hear me?
Yes.
Yes, I can hear you. Thank you.
Great. Thank you. This is Yue Song, and I will introduce our work about SRv6 midpoint protection. Next slide, please. Here is the motivation of this document. When SRv6 policy endpoint node fails, the existing local repair mechanisms, such as FR, cannot provide protection because the following reasons. First is the current repair path also traverse the endpoint, and also after IGP convergence, the repair path will be deleted along with the routine. So we propose this method, proxy forwarding mechanisms or midpoint protection. When an endpoint node fails, other nodes can perform proxy forwarding, bypass the failed node, and continue the forwarding to the next endpoint or destination. This is a useful supplement to TILFA and provides local repair mechanisms for SRv6 policies. This document defines the behavior of SRv6 midpoint protection, including extensions for transit and dot X repair node. Next slide, please. This slide shows the SRv6 midpoint protection mechanisms. Just as the picture shows, node E fails in the network, and the packet needs to bypass node E and be forwarded to the next endpoint node of the failed endpoint. In this picture, this is node D. So in the first step before IGP convergence, node B still keep the feed to node E, but the output interface is down. So the proxy forwarding behavior is excluded in node B. And with the segment left minus by 1, copy the next seed to the destination address of the IPv6 header and forward the packet based on the updated destination address. In the next step, after IGP convergence, all the nodes delete the fib of node E. For example, node A in this picture will be fib miss and triggering proxy forwarding or midpoint protection in node A. In step 3, after SRS's policy convergence, the node forwards the packet along the converged path. So this document actually defines the behavior of the step 1 and step 2. Next page, please. Yes, and here is the detailed description of the SRS's midpoint protection behaviors. We take an example when the repair node is a transit node. If the primary output interface used to forward the packet failed, this is actually the first step in the previous slide. Also, if the next header is SRH and segment left isn't 0, the failed endpoint is directly connected to the repair node. Segment left -1 updates the IPv6 destination address with SRH segment left. FIP lookup on the updated destination address and forward the packet according to the matched entry. Else forward the packet according to the backup next hop. In this case, the ordinary TIFA works. And another case, when the IGP convergence has already happened, there is no FIP entry for the for forwarding the packet. If next header is SRH and segment left isn't 0, segment left -1 updates the IPv6 destination by SRH segment left, FIP lookup on the updated destination address, forward the packet according to the matched entry, or drop the packet. Else forward according to the matched entry. Next slide, please. In the updated version, we end the section about security considerations. In this section, we define the midpoint protection cannot be enabled by default, and also the repair node can modify the SRH only when the failed endpoint is in the same trusted domain node. In other words, midpoint protection is only enabled when the repair node is trusted by the failed node. And next slide. And we ask the group to review the document, and any contributions and comments are always welcome. And we think the solution is mutual, so maybe we can also consider working group adoption. Okay, that's all. Any comments or questions?
So I don't see anyone in any comments in the Jabber window, nor anyone in the queue. So I think thanks for your presentation.
Okay,
and,
thank you.
Let's see, Huaymo we do have, I guess Sue Harris jumped on. No, let's see. Huaymo, you're still on here. Do you want to talk, or do you want to ask a question?
Which one?
Do you want to ask a question, or not? Okay. So I guess Huaymo hadn't muted, so it appeared that he might be on the queue. So I'll add Linda. Okay.
Chris, you said Steve Harris wanted to ask a question, or?
I think it's an artifact of
okay.
Maybe when people join, they automatically show up in the queue and it gets deactivated. Because I've basically seen at one point everyone has, or at least 50 people have appeared to want to send audio, but not that many people have. So let's move on to thank you. And so go ahead and unmute your audio, Linda. Okay.
Linda, we still cannot hear you.
So Linda sent a message saying, it says my audio is not permission denied. How about we jump ahead to Wim? If that's okay with Wim, perhaps we can jump ahead to Wim and come back to Linda right after Wim. Hopefully we can get the audio working. And Linda, as a means of troubleshooting your audio, if Wim doesn't mind, like if you're able to get audio and you think you've got it, then like speak and it will interrupt Wim's presentation perhaps, but we'll at least know we have audio. Oddly enough, I see Wim also sort of get kicked off, but go ahead and speak, Wim. Okay, good. Okay, thanks. Yeah. Okay, so we're going to go ahead and let Wim present. I hope you don't mind. If Linda gets audio connectivity, she's going to say something just to know we're good.
Yeah, no worries.
Thanks.
Yes. So we did in Singapore, we presented in the host series, and based on some feedback we got, people would love to have us to have written this draft. So as such, this is what we did. So this is the first time we present this, and I am presenting this on behalf of a number of authors and co-authors, which are listed here. So basically, it's an architecture for network function interconnection, which we'll go through in a bit more detail. Next slide, please. So first of all, what are we and what this is about is, first of all, we see that with 5G and IoT and Industry 4.0, we see that the number of new service requirements or requirements which you already had are changing, such as we typically had bandwidth, but there is definitely ultra reliability and then low latency coming into the mix. So we have to deal with that somehow in building networks. Secondly, we see that virtualization or software-based workloads are being added as workloads onto the network. So we somehow have to deal with that when we do interconnection of different functions. And third, we see that service edges are, so the boundaries of that are changing, and as a result of dealing with low latency, we have to deal with that somehow. So basically, what we did is wrote this draft, which we call NFIX. So NFIX stands for Network Function Interconnection, because when building networks, what we are actually doing is ensuring that there is connectivity between different endpoints. And as such, that's what we have, or what we are describing in this draft. Next slide. First, we introduced a few terminologies, which I don't believe are completely, let's say, defined in IETF. So first of all, we defined a PNF, so which is a physical network function. Then we defined a VNF. We did not distinguish between containerization or virtualization and stuff like that. So maybe this is something we can improve upon, or it would be good to get some comments upon. So we called it VNF for now. Then we have a data center border router, which we call DCB. And then we had an interconnect controller. So this is the controller that is helping in the network connectivity and being responsible for managing the NFIX fabric, if you will. And then we have a data center controller.
Can people hear me?
Yes.
Yes.
Yeah. I think, Linda, we reversed the slots, given that you didn't have audio. So I'll finish this, and then I think you're next, as far as I can tell. Right, Chris?
Yes, correct.
Yeah,
Hello?
So yeah, so that's basically the terminology which we introduced in this. Next slide, please. So as such, if you look to the requirements or the situation is that what you see is that besides physical network functions, we have to deal with virtualized workloads. So the service landscape is changing a little bit. And as such, what you see is that traditionally, people have been building wide area networks, and then people have been building data centers. And what we haven't done is having an architecture which is unifying that without creating service boundaries at the data center border router, because that creates complexities and scalability concerns. So what we are trying to do is building a unified architecture that combines either virtual environments, typically in a data center, and interconnecting them with traditional WAN equipment, which is basically building the wide area network. Right. Next slide. So as such, if you look at all of this, so it's about interconnecting or seamlessly connecting virtual workloads to virtual workloads, or virtual to physical, or physical to physical. So all of these combinations should be feasible. It is built on seamless MPLS, because if you look back, seamless MPLS architecture was actually trying to achieve or has achieved a similar objective. But what we see is that we are extending it to the data centers to deal with the virtualized or containerized workloads. Secondly, we see that we need to do traffic engineering, or having or defining SLAs which span multiple environments, meaning data center, wide area network. And as we all know, wide area network can be defined or can be implemented using multiple pieces of the network, like an aggregation, access, and core domain. So it's making a seamless fabric that, or service architecture that spans all of these environments. So as such, we are introducing segment routing. So at the moment we described it mainly with MPLS-based data plane, but all of what we described is working also in an SRv6-based environment. And then secondly, we are introducing the interconnect controller that is there to help in helping to define and set up environments with stringent SLAs, with KPIs that spans that whole environment, as well as having a view on the service and the topology, and understanding the full, having full visibility of that environment in a centralized way. We are basically using all kinds of protocols that are being defined in IETF. So as such, we are not defining a new protocol or new extensions. We are just using what is available or what has been defined in various working groups. Some of them are listed here. Next slide. So if you look a bit from the architecture, we are relying on the wide area network with the same capabilities as we have today. So we're using segment routing paths, and then supported by BGP-LU in the same way as seamless MPLS is using. In data center, we are introducing segment routing in various options. So there can be segment routing MPLS or SRv6, but also segment routing over IP or UDP as defined in RFC 8663. And then for interdomain, so if you have a best effort path today, like on the internet, we interconnect these things via BGP-LU. And then if there was, or if there are requirements for traffic engineering and more stringent SLAs that are defined by certain services, you can actually use SR policies that actually define then those KPIs and SLAs across that whole environment. We use colors to actually help define that intent of that KPI that actually is defined. And what we are doing is we're using the service, so the BSID anchoring is done at the data center gateway, because that helps to scale and also helps in scenarios that when you have convergence, ensures that we don't have to update all the elements. For example, if you look at virtualized workloads, there can be many endpoints that has to be updated in case of failure. So with this framework, we allow, or we avoid some of these issues. Next slide. From a service point of view, is we are mainly working with, so we are actually working with EVPN and IPVPN with either v4 and v6. So services are defined end-to-end, so there is no service stitching boundary at some point. So the services are defined end-to-end. And then, of course, we use, by the fact that we have head and color and endpoint and working in conjunction with the controller, we can then build virtual topologies. We can do service activation based on certain requirements. So all of these capabilities are possible with that framework. And so we leverage that architecture to achieve then basically what we said in the beginning, this building an architecture for interconnectivity between virtual and physical workloads with KPIs and SLAs end-to-end. Next slide. So this is the first time we presented it. So it is an informational draft. So given that we are not doing protocol extensions, we just describe how that whole environment can be put together. So it's an open framework built on various IETF work, and we actually have already implemented this in a number of environment or deployments using various vendors, so it's multi-vendor in nature. So as such, we are looking for feedback at this stage to see whether there are things that we would have to add or we would, or comments in general. So thanks.
Thank you, Wim. Any questions here?
Hello?
Yeah.
Hello?
Yeah.
Okay. Wim, can you hear me?
Can you please introduce yourself, Robin?
Okay. Zhenbin from Huawei. Okay, I will have the two comments on this, the architecture or the question. The first one is that will the WinF support the SRMPRs in the architecture? I think this may be a challenge work.
So are you saying, what is the comment exactly?
I mean, Wim, that means this is the interconnection because you depending on the SRMPRs. So I wonder if the WinF will support SRMPRs.
No, so yeah, so first of all, I think we described so far with MPLS data plane, but as I said, so this works also with SRv6. What you see is that in this architecture, the VNF or the virtual function, you can also have like a virtual switch or a service edge that sits underneath it that does that capability. So you have various ways to interact with that. So the VNF doesn't necessarily need to support that capability. And that is still supported with this framework.
So
okay. So actually, we're
so you
going
mean
to need
that
to we're going to need to cut the line and also end questions because we need to run a tight ship today because we'll be cut off at the 50-minute mark. So hopefully. We have access to Linda's audio at this point. Can you join, Linda?
Robin, please do send your questions to the list and let the author address them. Okay?
Okay. Okay.
Thank you.
Okay.
We were able to hear Linda earlier for a moment. Okay. So I think at this point we should go ahead to Chuan, and hopefully I guess at this point we'll try to fit Linda in at the So can you speak, Linda? Okay.
Hello?
Yeah.
Hello. I can hear you.
Can people hear me?
Yes.
Yes.
There's some echo, so.
Hello?
Yeah, now it's okay.
Okay. Should I start?
Please go ahead.
Okay. Thank you very much. So I'll get it quick. So I will, next page, please. Okay, since it's been a while since IETF106, we have made major changes to the two drafts. We have discussed with other working groups like DNS, Ops. We have discussed with people from NANOC, got very good feedback. We removed all the references to SD1. So mainly focus on the problems associated with branch connecting to cloud data center and applications in cloud data center interconnect with other application in other locations. Next page, please. So this is the restructured table of contents. So I highly encourage people to reread it again if you read it before. We have made some major changes. So primarily, we'll talk about, we added a new section on how do we reach applications with multiple instances in different cloud data centers. We added more detailed description on the DNS for the cloud services and also for the net. How does the like virtual CPE in the cloud data center be able to inform the its own controller of the net it traverses through. And we added a few more problems with multiple PEs access the workload in the cloud data center. Next page, please. So here's the highlight of the problems. I encourage people to read into the detail. One is the identity management, when we have a workload in different cloud data centers. First of all is the user authentication. Another one is application authentication. When you have one application in one place, try to access or call another function call in another one. Can be, that's a pretty big issue there. Second one is the API abstractions. That's all from last meeting. Since last meeting, we got feedback from people, primarily because different cloud data center have different interfaces. For specific features provided by a specific cloud data center, it's okay to have their own API, but there are lots of common services like firewall, net, all those common services is preferable to have a shim layer to be able to allow enterprise to move cloud to another one, move the service from one cloud data center to another one. And the last one we added is the basically we added more content in this cloud discovery. This probably is the area where we can do more work in the routing area. Basically to locate the workload in the most optimal places and discover services. Next page, please. So here's after discussing with DNS Ops and their feedback, we enhanced the description on the DNS. So there are two aspects for DNS. One aspect is the resolution, resolving the query from the application running inside the cloud data center. Because for enterprises, not all entries are hosted in a specific cloud data center. So the within one cloud, the resolution may need to forward query to the custom on-prem DNS. And customer, if the end target is in another cloud, this query has to be forwarded to a specific location to get the address for the application to talk to each other. So that's on the DNS provided by the cloud and how to they interface with on-prem DNS. Another part is application. As we know, most applications today have multiple instances instantiated in different places. And today, the state-of-art solution is using DNS as a way to forward the target into the closest one, right?
So, Linda, in
for
order
example,
to get
this
on
picture, you
schedule,
see that you have
we need to
application running
wrap
in
things
2
up in
data
1 minute.
centers. And through DNS, based on the location of the client, they return back the address of the closest one. This has their own problems. This is basically layer 7 kind of traffic management. The problems is it depends on the client behavior. If the client never refresh their cache, and if they try to move, like if you have a moving device,
Linda,
move to different
I'm going
location,
to keep
they still
talking and
carry with you
interrupt you here.
to the
Can you hear
previous
me?
location, which may not be optimal. Second problem is the network routing layer information was never being taken into consideration in finding the optimal location for the service. The network can be congested, network can have failure, and DNS still resolve to a specific location. So practically, it is the DNS achieve the traffic management. And because our routing domain has lots of information on the underlying network performance and status, we
So,
can
Linda, there
actually
appears to
have
be a problem
lots
with the
of
audio, that you're not able to hear
to
the meeting.
enhance
So
reaching
I'm going to mute
instances.
you. Okay, so there appears to be a problem with the audio still, in that Linda isn't getting the audio from the meeting. So we need to keep on schedule because we're going to get cut off. So let's move on to Xuan's presentation.
Hi, Jeff. Can you hear me?
Thank you.
Yeah.
Thank you.
Okay. Hi, everyone. I'm Chuan Xiong from ZTE. My presentation today is precise transport networking and related problem statement and requirements drafts. Next slide, please. So let me first introduce the use cases of precise network. As we were learned, the 5G networks need to provide 3 types of services, including EMBB, MMTC, and the URLLC. And the URLLC services cover the use cases such as Internet of Electricity, Intelligent Factory, Internet of Vehicles, and other industry Internet scenarios. And these services may demand precise and deterministic performance. For example, as the figure shows, the Internet of Electricity may demand service isolation and high security other than precise latency, loss, and jitter. The Internet of Vehicles and remote medical has special requirement for interoperators deployment. And the last one, the AR/VR service must provide precise control for dynamic flows from multiple users. So last slide, please. So based on the use cases, as we will learn, there are existing technologies in IETF to provide deterministic queues, such as Untitled working group. But besides latency, jitter, and packet loss, more other precise performance should be provided in precise network. The figure shows the different requirements between deterministic and precise networks. So first, as RFC H655 defined in Untitled working group, the primary goals for Untitled queues is as the on the left, the Untitled queues is minimum and maximum end-to-end latency and low packet loss. But for precise network, it would provide precise latency, packet loss, and jitter. Second one, the basic mechanism in deterministic network is the resource reservation, but in precise network, we should require resource and surface isolation. And the existing technologies provide deterministic performance in forwarding layer through cycle and queen management. For example, such as the mechanisms provided in TSN. But in precise network, the candidate mechanism would be flexible slicing turner. Finally, the Untitled working group in the Untitled Chapter, the Untitled working group mainly focus on domains which are in a closed group of administrative control, but the precise network will cover the scenarios which may belong to multi-administrative controls between multiple operators. So this is the large-scale scenario, and then the deterministic networking. So last slide, please. So based on this precise requirements and the existing issues in existing technologies in IETF, so we propose to discuss the problem statement for precise network. And the problem statement draft, we discuss the problem with traffic scheduling mechanism. For example, the mechanisms such as queuing, shaping, and the scheduling functions. The mechanism in PSN will not be appropriate for IP networks. Second, the problem with long-distance transmission delay and jitter. It will lead to uncertainties such as increasing transmission delay, jitter, and noise. It must be considered in precise network. We discussed the problem with dynamic flows for multiple users. We must provide precise control for dynamic flows from multiple users, but this is not considered in the existing mechanism. The flows lead to aggregate in that working group. Next, we discussed the problem with the service isolation and the resource allocation. This is not considered in existing solution. The existing solutions can only achieve the resource reservation. So next slide, please. So we, based on the use cases and the issues, we propose the requirements of precise network, such as the precise latency, jitter, and packet loss, the precise and flexible resource allocation, surface isolation, and the high reliability and the precise OEM, high security, and multiple operators and the multiple administrative controls, and the dynamic flows for multiple users. And these requirements have been discussed in the last slides. And more other problems and requirements may be also added in the future. So last slide, please.
You've got 1 minute.
Okay, thank you. So we mainly focus on the 5G transport network and propose the precise transport networking based on the existing technologies such as DETLAT, SR, and we may also propose other candidate mechanisms to resolve the above problems and meet the requirements. So we define the precise transport networking to provide the precise SLA guarantees and the precise control, such as the flexible resource allocation and service isolation, and the or more other precise services. And we will cover the following scenarios. For example, single operator, multiple operators, and multiple operators for a closed group of administrative control or multi administrative controls. So as the figure show, this is the 5G transporter network. We need to provide end-to-end precise SLAs for this transport network.
So excuse me, we need to cut you off here in order to stay on the very strict schedule.
So just short comment from my side.
Thank you as well.
It's really interesting work. Please make sure anytime you identify gaps, you have references to either TSN, WRF, or DETNet in IETF. So people don't need to do cross validations. It would really improve readability. Thank you.
Thank you.
Thank you. Next up is Sui Tian.
We cannot hear you.
Zhenbin, did you have something to say?
Okay. Since Hui Tian has some issue, so I will do the presentation. Okay.
Okay, thank you.
Okay. Yeah. So here, this is the one more the discussion about this SRv6 deployment consideration. Here we have some the updates. Okay, next slide. Okay, so here there are two important drafts to describe the SRv6 deployment. The first one is the SRv6 deployment status. It introduces the deployments of the SRv6 and also the industry activity of SRv6, including open source and also the tools for the SRv6, etc. And this draft, the SRv6 deployment consideration, it will introduce some of the design experience for the SRv6 deployment. Okay, next one. Okay, so here we introduce some of the SRv6 advantages. In fact, this already presented in the last meeting. So here I just briefly introduce I think this the first one is the IP route aggregation. So that it can improve the scalability using SRv6 comparing with the SMPRs. The second one, I think, because the SRMPRs is to design the sRGB and the node ID search resources across multiple network domain. So this is a little difficult. So the SRv6 can set up the end-to-end tunnel based on the IPv6 reachability. So this can ease the design burden. The last one, I think this is the on-demand upgradation of the SRv6 because the need not to the entire network to upgrade to support because it can be compatible with IPv6. So it can use the IPv6 reachability to cross the node which cannot support SRv6. Okay, next slide. Okay, so here this is the incremental deployment guidance. So we think that's the we can directly to enable the IPv6 reachability. So then the second step we will can deploy the SRv6 VPN. It's only need to upgrade the edge node to support the SRv6, and then this is can support the SRv6 for the intra-domain. So means that the P node can be upgraded to support SRv6 to support the SRv6 traffic engineering or the SRv6 the TRFA fast reroute. Okay, next one. Okay, so here this is the deployment cases. So this is the China Telecom. So this is across the backbone. So this is here is the data center network across the backbone. There's the two backbone. So and also this one backbone only support the IPv6 reachability. So at that time, it's very hard for them to support the MPLS VPN services. But now that it can utilize the IPv6 reachability to support the VPN. So then that is go on to use the SRv6 policy to choose the different backbone because it has the two backbone. It can according to this the congestion situation to choose the possible this the backbone network. Okay. Next one. Okay, so this is a China Unicom. So this is for the cloud service. It also need to cross multiple backbone. So this is the backbone, and also now this only support the native IPv6. It can also utilize this the IPv6 reachability to support the VPN service to set up the VPN lease line service. Okay, next one. Okay, so this is the interesting, this is the SRv6 deployment. So that is the MTN, because it has a lot of this has a multiple network domain and also is a lot of configuration according to this the older service provision. It utilize this the VPN or inter-AS services. That is a lot of this configuration. And also this infrastructure is not stable. So it always failure happens and cause the complaints of the customers. So now that is use end-to-end SRv6 to can seamlessly seamlessly that is set up this cross multi-domain this the path. Then this is also deploy the TRFA to support this the reliability solutions. So this is comparing this the traditional the traffic engineering combined with the BFD. That is a lot of huge of configuration. But now use the SRv6 and the TRFA, and this the configuration reduced hugely. Okay, and also is improve the reliability of the network and also reduce the complaints of the customers. Okay, next one. Okay, so here this is a summary of this the commercial deployment in China. So now that's almost more than 10 deployment of SRv6 for the different scenarios for the 5G transport or this is the cloud service. And now this key features is the VPN and the best effort. But now let's move on to the traffic engineering and also the policy. Okay, next one. Okay, so this is the next step. We will also this is more deployment cases and also different this design experience for using SRv6 for the 5G transport or the data center, etc. And also we know that now there is a lot of discussion about the SRv6 compression. So we also provide this the experience about the design of the IPv6 address and also the SRv6 locator design, etc. Okay, so that's all for my presentation, and also this feedback and the comments are appreciated.
Thank you, Robin. Any questions?
Thanks. We have 1.5 minutes or 1 minute for questions, if anyone's there.
Okay.
Wim. Yes, Wim, you are unmuted.
Have you considered the RFC 8663 in the comparison? Because I believe some of the statements are incorrect if you take that into account. With respect to the comparison with SRMPLS versus SRv6.
Okay,
we'll do it offline. I'll send a mail on the mailing list. It's probably easier.
Okay. I think this is an interesting topic.
Okay, one more question from Tony Lee, and then the line is closed.
Okay.
Hi, have you considered adding some considerations about bandwidth overhead?
Sorry, Tony, I not catch the last words. What's your mean?
Have you considered adding comments on overhead? How much bandwidth are you
Overhead.
consuming?
Okay, I think that's your concern about this overhead of the SRv6. I mean that maybe you can refer to some of the draft in the spring working group that is discuss how to compress the SRv6 overhead. So that's for our.
I'm interested in your deployment experience.
So can we take these questions to the list because we need to move on to Shuping's presentation.
Okay, Tony, I will propose this information for your reference. Okay.
Okay, Shuping, the floor is yours. Thank you.
Hi, thank you. This is Shuping. I'm going to introduce the latest updates on APN application-aware networking. Next, please. Here is the overview of the APN, the application-aware network. Actually, we mainly focus on the application-aware network domain. As to the application information, they are delivered into this network domain. And based on this information, more new network services can be provided. As to those application information, that could be added or encapsulated at the application in the terminals or at the network edge devices, but they are outside of the application-aware network domain. Next, please. And there are three key elements of APN. First is about application information, including the application-aware identifiers, as well as the service performance requirements. And those application information are open and not mandatory. They could be added based on the agreement. And the second is about the rich network services. There are more and more new network services emerging. So with the application awareness, more new network services are going to be provided. And third is about network measurements. Currently, we have a lot of techniques for the network and the service performance measurements. With application awareness, we could achieve more accurate and fine granularity and comprehensive measurements. Next, please. And here are some potential work items in APN, including both new work and the work that needs to be extended. So first, in the data plane, the existing encapsulation may need to be extended, for example, IPv6 and SRv6, in order to carry the application-aware ID. And in the control plane, the existing protocols may need to be extended to advertise or exchange the application-aware ID. As to the architecture, we would need to define the APN framework and the key functional components. And on top of that, we would need to explore what would be the new network services can be supported by APN. Next, please. And here again, regarding the APN scope, we would like to emphasize that the APN application-aware network, we would only focus on the network domain, and the application information describing the service or behaviors needed by the applications could be added by either the application or the edge devices. If those information is added at the edge devices, there will be no privacy or security issues since those devices are controlled by the network operators. But if they are added at the application itself, there may be something we need to consider. Next, please. And here we compare it with the PAN-RG, and we could see that they are actually work in the opposite direction. For the PAN-RG, that is the network providing information to the application, and the application could utilize those information to select the path. Next, please. And here, there is a hackathon on APN6, that is APN over the IPv6 data plane. And you could find the information in the links. And in this hackathon, the implementation of APN6 is demonstrated, and including the IPv6 encapsulation for the application-aware ID, as well as the service parameters. And based on those application information, the SRv6-based traffic steering is demonstrated. Here are some specifications. Next, please. And we are also hosting APN side meeting this Thursday, and the time here is the time and the Webex. You are very welcome to join the discussions there. And in this side meeting, we plan to have the following topics. First, and we would like to discuss and clarify the similar attempts in IETF history, especially on the BOFs for the SPAD and PLUS. And we would like to discuss what lessons we can learn from them. And then we invite some operators to present their use cases to show the requirements for the application awareness in their network and what could be the benefits they could achieve with APN. And then briefly about the APN framework. And then is in the IETF, currently there are some proposals on the acquisition, encapsulation, and convening of those application-related information. And we also invited the experts to present those proposals. And at last, but this most important thing we would like to discuss and clarify, that is about the privacy and security issues. That is the two issues the APN got challenged the most, and we would like to discuss with people. Actually, on those two issues, we have already have done some studies. Next, please. This one is the privacy issues, and we have analyzed those scenarios, and we found that probably in most scenarios there will be no privacy issues. And the first one, and we know that more and more operators are started running their own applications. Like in China, CMCC, they have Migu Music. I believe in your countries, you also have the similar applications run by the operators. And there will be no privacy issues because operators own those applications. And then for the application providers, and more and more application providers are building and running their own networks, like Google before. So Google actually control the application service till the end of the edge of the network, the LAN. So it controls everything. And it also differentiates those important applications to give them higher priority. And then the third one is APN actually works only within our operators control the limited domain. So no matter where the application information is added or encapsulated, so there will be no privacy issue. And if the application information is added at the edge devices, but those devices are controlled by the network operators. So again, there will be no privacy issues. Those edge devices could be, in different scenarios, could be edge enterprise CPE and home broadband residential gateway, broadband network gateway, Wi-Fi, the access point, and 5G core, the user plane function. And then is if those application information is at the application, if those information is encrypted, again, there will be no privacy issue. So only scenario will be if those information is added at the application, but they are not encrypted. So in that case, we may need to think about the privacy issue, and probably we need to think more about the coding of the application information. Next, please.
You've got 1 minute.
Yeah, sure. And this is about the security issue. And again, we classify the scenarios. So in the inter-DC scenario, we found there is no security issue. And for the enterprise scenario, generally they access, so the enterprise users, they access through a controlled BNG interface that is authorized. So here on the right side of the slides, I showed on the top is typical fixed broadband, and then on the bottom is typical 5G mobile broadband. The typical network deployments and service provisioning, you could see the setup. And from there, for the fixed broadband, the BNG is acting as the network gateway, while for the 5G mobile broadband, it's a 5GC, and it's authenticating or authorizing the user access. So the APN will only impose security issues when the users access from an untrusted domain. But in the home broadband scenario, that could be validated by the BNG. In the mobile broadband, that could be validated by the 5G core. And there also, we listed four types of security issues. The first one is within one terminal. And that could be, the situation could be one application in one terminal as arbitrary application information. And also those application in one terminal could add the application information of another applications in the same terminal. But both cases can be tackled via the operating system. If they finally are sent out, it can be blocked via BNG or the 5G core. And the second case is once those information is sent out, that can be still validated via network side security solution. So for example, the application in one terminal forges the application information of the same application, but in another terminal. And all the application information is tampered along the way between the application information creator to the network boundary. So here are the four types of security issues we can think of. Next, please. And here are the related information about APN, including the problem statement and use cases. And here we have the two operators draft. One is about APN in the edge computing scenarios, and the other one is about APN for the gaming acceleration use cases. If you are interested, you could have a look. And then framework, and then the requirements, and then the community. And in this community, and you could find the latest updates on APN, including the Infocom paper we just published, and the Interop Tokyo. We got into the finalist to show the APN demo. So we would like to get your feedback and welcome you in the side meeting and to join our discussions. And thank you. That's all.
Thank you. We've got 1 minute for questions, if any.
Linda is in the queue, but okay. No, that appears to be an error. I'll just check. There don't seem to be any like specific questions on the chat window. Okay, so we have 5 more minutes. And so if there are no questions on this presentation, next up is a presentation by Khaled Omar.
Okay, thank you.
Thank you. So is Khaled here? Is he present and able to share his audio? Okay, so I don't see Khaled on the list of participants logged in. So let me check the chat window as well. See if, oh, Drew confirming that he doesn't see Khaled as well. So at this point, I think we should probably just go ahead and close the meeting, because I think trying to do a little discussion right at the end is going to really just get cut off right in the middle. Yingzhen, do you have a comment?
Khaled just sent me a message. He probably doesn't know the link to join the meeting. I'm sending him my email. Just hold on a second.
Okay, great, thanks. Well, I'll say right up front, thank you for your participation, because if Khaled manages to join, from my previous experience, he'll be able to speak for about 2 minutes and then be cut off by Meet Echo unless that feature or bug has been fixed. So thanks for your participation in this this meeting, and we'll sort of wait for Khaled to join. I think Stuart would like to talk, so go ahead and jump in, Stuart. Oh, okay. Well, we have a message from Meet Echo that rooms are not cut off automatically, so that's good. So we'll wait on here for a few more minutes to try to resolve Khaled's connectivity issue or access issue.
Yeah, probably for the next IETF, if we stay online, we should have either 2 slots or at least larger slot. Getting really, really crowded.
Any update on progress, Yingzhen?
No, I don't see him join me. Yeah. Double check. He sent me an email asking me the link to join the meeting. I'm not sure why he doesn't know that. So it was in the middle of the meeting. I didn't check my email in time. So.
Okay, yeah, no problem. So we have Praveen Madha. Let's see. Hello, Praveen. You're unmuted.
Hear me, Jeff?
Please talk louder.
Could you hear me now?
Yes.
Yeah. While Khaled joins, I have a quick question on the naming convention of the protocol. Can we have our names like a Khaled routing protocol, something like that, even in draft versions? Would you like to comment on that?
So basically, an individual draft can, I think, have whatever, as long as it's not offensive or anything, can use whatever convention they like. A draft that would get adopted. During the adoption process, I think a lot of people would have input as to what naming conventions are used.
So we are running out of time. I would propose to send any comments with regards to KRP to the list, and hopefully Khalid will address them.
Yes, I agree. So thanks, everyone. And we hope to hear from you on the mailing list, of course, and at the next meeting, either interim or scheduled.
Stay
regularly scheduled.
safe, everyone, and we hope to see you either virtually or in person in where are we going to be? Probably home. Thanks, everyone.
Okay, thanks a lot. Bye-bye.